yeah, pure awesomeness. So I have this inverter configuration, whatever you want to call it, hooked up, and there is an important note to make here that it is imperative that both of these inverters have the exact same input voltage. If they don't, they won't share current properly, and they may turn off each of their various input stages because they think that the voltage is too high or low, etc. So you need to make sure that they both have the same voltage. Now, I have them both connected up to the same batteries, so that's not an issue. They're both powered through the same cables. These are 2-gauge cables, so that's not an issue. But this is how I have them hooked up. So the inverter on top gets the negative cable from the batteries. The inverter on the bottom gets the positive cable. And then I connect them both together through some other wiring. These happen to be 6-gauge wires. That's not optimal. I tried to use 2-gauge, but because these terminals are so close together, the rings had a danger of contacting, and I don't want to short out my batteries, so I used 6-gauge cable because that's what I had that had appropriate sized ring terminals. But anyway, this way each of these inverters gets the exact same voltage because I see the exact same resistance from the battery. This one up here gets the negative cable directly from the battery, but the positive cable has to run through this all the way around over here, then it connects up to the battery. Same way with the bottom one. It directly gets the positive cable, but the negative has to run through the 6-gauge cable up to here before it gets back to the battery. So they see identical voltage drop for both of them, assuming that they share the load identically, which they won't, but it'll be pretty close. And we'll demonstrate that here, but in the meantime, this is the inverter setup. On the output, I have my super meter plugged into this power strip, so I can turn it on and off when I want. This will show us the volts and watts and whatever else we want to see. And initially, at least, just to test this thing out, I have some dummy loads, a heater, and some light bulbs. Yes, they're not realistic loads for an inverter setup, but they're very good dummy loads, just to see if this thing even works. Or if it just, makes a lot of smoke and is great for the 4th of July or something, I don't know. But, so I have these all hooked up. They're connected to the batteries. I have my clamp meter on it, so we can see how much current is being drawn from the batteries. And they are protected by fuses, so I'm not terribly worried if anything horrible happens. It's limited to about 50 amps per inverter. That'll give me plenty of time to disconnect cables or whatnot. I don't really care. Anyway, so I'm just going to turn on the top inverter first. So only the top inverter is on. The bottom inverter is doing nothing. Nothing at all. So we'll turn this thing on here and take a look at what our voltage is. Okay. And I'm going to plug in some electric lights. This goes to my light bar over here. I don't know what I have plugged in, so I just plug this thing in. And it looks like I have 3 light bulbs on, which ends up being, once I get to the correct mode here, 235 watts. So anyway, the input current is 21.8 amps. I'll turn this off now. So my load is off. I'll turn on the other inverter. So now both of them are on, and they are on in parallel. That increased my amperage draw here by 0.1 amps. But when I turn on the light bulbs, both inverters share the load. You can see that the voltage is pretty much the same as it was before. Really no difference here. And our current is 22 amps. If I shut this one off, it goes to 22. Didn't change. Well, that's not what I was hoping to demonstrate. What I wanted to show is that the efficiency is different when you're running off of just 1 versus 2. And apparently I found the crossover point, which is about 250 watts. So let's turn on some more wattage here. Turn on a couple more light bulbs, and now we're drawing 430 watts, which is maxing out this inverter. So you can see that it's 42.7 amps approximately. I'll turn on the bottom inverter now. And you can see that the amperage draw dropped. So when these inverters are fully loaded, they're not as efficient, so when they share, they're more efficient. So by strapping these two together, we're getting a more efficient inverter. And let's also check one more thing. 116.8 volts when I'm running both of them in parallel. If I turn off the bottom one again, you can see that the voltage actually is pretty stable. Kind of surprised by that, to be honest. Alright, well, in any case, you can see that both of them are running in parallel, and it seems to be working quite well. When I turn on each one, each of the fans turns on separately, which is pretty good, and I'm just going to quick check my connections, make sure that they're good on here. And they seem to be. Check the outside case of each. Neither one is warm, so everything's good. So, they do seem to function. Now, let's see what this inverter by itself is capable of, and then see what both of them together are capable of. This is a 400 watt inverter. You wouldn't expect it to be able to do very much. Let's check and see what it can do. First of all, we're going to check out this electric heater because it's already on my table and it's easy. So I have just the one inverter on. It's operating very similarly to how it would operate if it was by itself. It is a little bit better. I beefed up the input traces on it, and also it's sharing the output capacitor, which does help its output capabilities. But the other inverter is off. The input stage and the output stage is not running, and it's really not doing much at all. So I have this heater here set on low. It should be somewhere around 600 watts, and we'll see if this 400 watt inverter can power it. Now keep in mind there's no actual overcurrent protection, so I'm not going to power it very long or these fuses might trip. But I'll plug this thing in and see what happens. The fan turns on, and the voltage is pretty solid. Oh, there we go. The inverter just shut off. So it's cycling on and off. It can't power it. So now I'm going to go over here and turn on the bottom inverter. Now both of them are on. So we'll see if this now 800 watt inverter can power this heater. Plug it in now. Both fans turn on. Voltage is good. We're drawing 550 watts. And it seems to work. So I'll turn this up to medium, see what happens. This heater's on medium. It is drawing, well, the wattage that you can read, over 800 watts. And the air is nice and warm. It seems to be running pretty well. It's 115 volts, and we're drawing 84 amps out of the battery. So these two inverters can do 800 watts, at least for a little while. I assume they'll overheat after a little bit. Let's try the heater on high. Nope, it can't do high. It's just cycling on and off, just like before. So, putting these two inverters in parallel like I've done, you might want to do something more permanent than strapping them together with electrical tape, but this is just a test prototype. Has worked pretty well. It does seem to be able to output 800 watts for a heater, and you know what, let's have some fun with it. At least what I call fun. So let's see what these inverters can actually power. Hi everyone, now I'm in my basement, and this cord is plugged into the inverter. You'll just have to trust me on that. But both of the inverters are on, and this being lit up shows that the inverter is working. The inverters are actually upstairs. I didn't want to haul all this crap up there, so I didn't do it. So hopefully they don't start on fire. If they do, I'll have to run upstairs and put it out. But this light's on, the inverters are on, and let's see what this thing can power. So behind the camera I have a 500 watt halogen work light. Let's see if it works. Works very nicely. So yes, this inverter can power a 500 watt halogen work light. Very good, but not too much of a surprise. It's supposed to be an 800 watt inverter, right? So let's try something else a little bit more demanding. Over here I have a 3 horsepower shop vac. Yeah, it looks pretty small, but it's got a pretty good sized motor on it, and it usually takes a 1500 watt inverter or so to power this thing. Let's see if this little 800 watt jobby can do it. Nope, it cannot power this vacuum cleaner. Not a big surprise. It does take a pretty good inverter to power this thing, and because the light's on, you can tell that it's still running. Didn't explode yet. So let's move on. Can't power that. This is a 13 amp circular saw. I would be really surprised if it could power this, but you know what? Let's give it a try anyway. It's on, the light and laser's on, pull the trigger, and it almost powered it, surprisingly enough. Let's try this again. Nope, just can't do it. But you wouldn't really expect a couple 400 watt inverters to power it anyway. Let's try this window air conditioner. I'll plug this thing in. Now, air conditioners are very, very difficult to start, so I wouldn't be too surprised if I can't run this thing, but let's give it a try anyway. Let's see, fan on low, turn the air conditioner on, and see if it works. That's rather disappointing. Apparently it's too cold in my basement to even test this out. So, well, I apologize for that. But I do have here a dehumidifier. Now, this takes about 600 or 700 watts to run and a lot of power to start. So, let's give this one a try instead. This usually takes a 3000 watt inverter to start, so I have almost no confidence in it, but we'll give it a try anyway. Nope, couldn't start it. So, I didn't have a lot of luck with stuff down here, but most other modestly sized appliances should run. Let's try one other appliance that a lot of people might want to run off of an inverter like this. And beside me over here, I have a mini fridge with a jug of flammable liquid on top. Everybody should have one of these in their basement. So, let's try this out. Let's see if this will run a mini refrigerator. Now, this only takes 100 watts or so to operate, but it takes a very high startup surge. So let's see if this can power it. I'm rather disappointed. It's not able to start this mini fridge. Well, can't even run a mini fridge. That's a little bit of a disappointment, isn't it? I ran upstairs quick to check and see why this inverter setup was performing so poorly, and look what I found. Blown fuses. These are 20 amp fuses. Obviously not enough, so I'm going to replace it with 30 amp fuses. That's a safe way to do things, right? If the fuse blows, just use a bigger fuse. But to be honest, this initially came with 25 amp fuses. All I had was 20 amp replacements at the time, so that's what I used, but I'm going to put some 30s in there, and then we'll do all of these tests again, because at some point during those tests, these fuses blew. And we were only running all of these appliances off of one inverter, and it couldn't power it. So I will replace the fuses, and then we'll do round 2. Fight! Well, it turns out all I had were 40 amp fuses or 20 amp fuses. So 2 40 amp fuses should be enough. That's 80 amps, and let's do all of these tests again, because before I was only running on one inverter and I just didn't know it. So I have my mini fridge. And I also just realized that not only do I have a 5-gallon jug of highly flammable liquid, I also have a 100-pound propane tank in the background. Seems like a perfect place to make sparks, doesn't it? So, let's see if it can power this mini fridge. And yes, it powers it just fine. So, that inverter by itself can't power it, but both together powers it just fine. Let's move on to some of the other appliances. Alright, moving on to some of the retests. Now, the halogen light that is again behind the camera, I'm sure both inverters were running when I plugged this in the first time, but you can see that it still works just fine. Of course it does. And at some point after I tried to power some of these heavier loads, the fuses blew. So, first of all, I'm going to try this fridge, because we weren't able to try it last time. This time I have this electric heater blowing on it, so now it thinks it's hot in here, and it will be more than happy enough to run. So, this is a 5500 watt, 5500 BTU window air conditioner, and this usually requires a pretty good inverter to power. It is an air conditioner with a compressor inside it, but it is set to on, and we're going to see if this inverter can power it. Here we go. No, it cannot power this air conditioner. just cycles on and off. So it can't power the air conditioner. That's a little bit of a disappointment, but not a huge surprise. So let's try this vacuum cleaner once again. See if it can power this. Now vacuum cleaners don't have as high a startup surge as an air conditioner does, so there's a chance. We'll see. Oh yeah, it powers that just fine, no issue at all. So let's move on to the 13 amp circular saw. Now keep in mind that circular saws have a massive startup surge for a very brief period of time, but they don't require a lot of power to start. They just take a lot of power. So if your inverter sags a lot, they'll still be happy with that. Now if you go to cut something that's really tough and really bog it down, then it's going to stall out on you and it's not going to work very well. But maybe this inverter has a chance of starting the saw up. So let's see if it works this time now that we're running on both. And with a little bit of encouragement, it does indeed start up. We're powering this 13 amp circular saw on 410 watt inverters. Yeah. Can anybody else do that? Well, if you have two 400 watt inverters, you probably can yourself after watching this. Now, this dehumidifier is not going to start if the air conditioner didn't, but just for completeness sake, let's plug it in and prove that it doesn't work. Yeah, it doesn't work. So, there you go, some various different appliances. And actually I have one more. Let me bring it into frame here. Alright, behind me here I have a Bissell 12 amp vacuum cleaner, which is a terrible vacuum cleaner by the way. So anyway, a 12 amp vacuum cleaner, and I'll plug it into this dual 400 watt inverter setup. I don't expect it to work, but it's here in my basement, so let's give it a try. If I can get the polarity right on this thing. Wow, how about that? I don't know how long it would power it, but it does power the 12 amp vacuum cleaner. Now, there's one other thing that I always, and it's still running, there's one other thing that I always like to review on inverters, and that is their surge capability. And if you watch my other videos, you know that that is very, very important. Now, while I've been doing all of this testing, I've had an instrument running upstairs to measure the surge capability. So let's run upstairs and take a look at what it shows. And here's our inverters, both of them still running through the power strip, and my 12 gauge 50-foot extension cord running downstairs, and the two batteries, etc. But the instrument that I have is this clamp meter. So I had this clamp meter set on max hold. The maximum current that these two inverters drew was 160 amps. Now that is approximately a 1,600 watt surge. So these two inverters together could do a 1,600 watt surge, which is pretty good. 800 watts continuous, 1,600 watt surge. You can't ask for a lot more than that. It could power all sorts of stuff that a 400 watt inverter can't, and this overall has been a pretty successful experiment. So yes, you can take two inverters, put them together, and double the output power. It's not as simple as just connecting them in parallel with a hacked extension cord, but this method does indeed work. And here's the aftermath of my dual 410 watt inverter power hack. Anybody can do this. It just takes a soldering iron, a little bit of solder, and yes, you can double the power of an inverter. This won't work on all inverters. It depends on their construction. On these it worked especially well. On others it may not work quite as well, or it may take some more intricate work. Of course, if you do attempt this yourself, be aware that there are high voltages involved, high currents, and it could be a safety hazard, so don't do this unless you think you can tackle it. But I thought this was an interesting project. I had wanted to try this for quite some time, and I was rather surprised by how easy it was. Yes, two inverters, doubled output capacity. It works. And still, just by checking the thermals of this inverter just with my hand, I can tell that the input stage is more stressed than the output stage. So the output stage of this inverter is still just fine. It's still the input stage that's more stressed, which is kind of interesting. You would think that when they design something, they would make it so that all parts are equally weak or equally strong if you're an optimist. But in this case, it really does appear that the input stage is the weak stage. So putting them in parallel works especially well. You can utilize the output stage to its full capability and double up on the input. And then you get your 800 watt inverter, 1600 watt surge. This is Neurolar. Thanks for watching.